Now that you have your game kind of started, let's talk a little bit about what our logic is for how we're going to organize our game. So, on your Google Classroom, there is a link to the website, same website that you've seen before that has all of your other stuff on it. Um, just called Unit 3 website link, should be at the top of your stream. It should be right next to the Unit 3 physics game playlist. But if you open up just noxgamedesign.weebly.com to get to it, if you go to Unit 3, it'll give you this page that has kind of a little breakdown of what the unit is going to be. And then if you hover over and click on Game Outline, it will take you to this page. So here is kind of a description of our logic. I'm not going to read it all out to you because you are capable of reading it for yourselves, but basically what it boils down to is when you build a game, the first thing you have to do is decide what is the core of your game. What are the things that you have to have in it to make it functional? And you start with those things. You get those things worked out, and then you add on the other stuff at the end. So I've broken down for us what I think of as the core elements and then secondary elements. So, core elements, we need the paddle to be able to follow the player's mouse. That's what we're going to tackle in this video. We need to be able to figure out how to shoot the ball from the paddle and then bouncing around using physics. The bouncing we've got done, right? We've added 2D physics to our ball material, so that will bounce. We want to make sure our obstacles bounce the ball, which right now they bounce on the obstacles, so that's fine. And that the goal triggers a move to the next level, which is where that turning the goal into or collider into an is trigger, setting that to true, meaning that the ball, when it passes through it, it goes on to the next level. Secondary elements. These are things that aren't necessary for the game, but are definitely things that we want to include. So we want to be able to have a running score, basically meaning that between levels, the score is kept and then rolls over to the next scene and continues building up until the player loses. Some of the obstacles, we want them to be breakable. This is where that kind of block breaker part of our game comes in. We want some of our obstacles to be moving because I think that'll just really add some elements, like some fun elements to it. We want to add some sound effects and we want to add some particle effects to make basically these are both things about polish and ultimately you're going to be changing all the sprites around to make everything look exactly the way you want it. So that's where that comes in. So if we go into Unity, this is what we have right now. And the first thing on our core list was that we need the paddle to follow the player's mouse. So whenever we move our mouse, we want the paddle to go with it. Because right now it just sits there in the middle and it's not connected to anything and there's no script telling it what to do. So on scripts folder, we need to right click, create, C# script, just like always. We're just going to call it paddle because everything in this script is going to be relating to the paddle and how the paddle is going to function. I'm going to drag it onto the prefab paddle down here. If I were to drag it up here, that would be fine, but I would also have to apply it back to the prefab, remember, because I'm changing something that's in my scene that is a prefab down here. So I'll just do this real quick as an example. So if I were to drag this onto paddle right here, and you see whenever I click on this one, there's no script. So the script is added here and it's not added here. So in order to get that, remember with prefabs, if you change anything on the scene inserted ones, you need to hit apply. And now that bold script has gone away. And now this has the script on it. But normally I would just drag onto the prefab and then not have to worry about it. That just makes life easier. So open up the paddle script. And remember, mine looks a little bit different than yours because I'm working on my Mac now, but ultimately it's exactly the same. It's just a different layout, but I've changed everything so that it should look pretty close. So blank script. This should be something you are pretty familiar with because whenever we start a new script, that's what it looks like. So for our process for this, we need to first do a couple of steps to get it all set up. So at the top, let's serialize a field. One thing that you will notice that is very much different is on my screen, it's not going, the IntelliSense, the thing that tells you when your game or when your code like gives you those little hints, it pops up a little bit differently, but don't worry, it's still the same thing. So I can still hover over or double click on something and it'll highlight like all the places there where it is. So what I just did, serializing a field, we're making a float type variable, which we haven't really talked too much about. But a float is basically a number that could be any number. It's just an integer that can also have the ability to have decimal points. Floats are very useful, flexible type of variable. We'll use it quite a bit. And we're making a float variable here called screen width units. The reason we are doing this is because Unity wants to needs to know how wide our screen is going to be, and we're just giving it this number saying it's 16 units wide, and using that to pass in our information. Let's fix these so that they're on one line, because that's how I like my code to look. If you don't want to do that, that's all fine. Okay, so our second variable we need to make, we don't actually have to serialize this variable because we only ever need to access it inside the paddle. So we're going to put it down here in the update method, and it is going to be another float. And we're going to call this one mouse position. Oh, that's not how you spell mouse pause, meaning position, just shortened. Mouse pause units. So we're going to take the mouse position and we're going to turn it into, using our screen width units variable, we're going to turn it into something that Unity can use. So we're going to put Input.MousePosition .x, because we don't need our paddle to move up and down, right? We only need it to move side to side, and we know that that is the x variable. We're going to divide that by screen.width, which is going to be multiplied by screen width in units, and semicolon. So this is just what Unity thinks its screen width is in points. We're multiplying it by the screen width in units and dividing it by the mouse input x. It's just a way of saying basically, here's your version of what you think this looks like. Here's our version. Let's merge them together and use that to find our mouse input. Now we need to take this variable and use it to change the position of the paddle position. So real quick, we'll just take a trip over to the Unity scripting API. And let's look up vector2. You don't necessarily have to do this. You can just watch me and follow along. But this is something that is going to come up a lot throughout the entire time you make games and the rest of this course. You will be dealing with a lot of vector 2s and vector 3s. So description of a vector 2. A vector 2 is a representation of 2D vectors and points. The structure is used in some places to represent 2D positions and vectors, texture coordinates in a mesh, or texture offsets in material. And in the majority of other cases, vector 3 is used. So basically, a vector 2 gives a position. It tells your game what position a thing should be in or should be moving towards. So there's a bunch of methods associated to it, like move towards, which moves a point towards a current target. I can't talk. So like, say for example, you had an enemy in a game that was supposed to move towards the player, like maybe it's a zombie and they're like kind of homing in on your player. So you would use on that enemy a form of vector2.moveTowards and connect it into your player so that your enemy would always be kind of slowly meandering towards your player. Um, that's kind of what that does. Basically, it's just points on the screen. It tells you how to direct things. So we're going to use vector2, and we're going to create a new vector2. We're going to call it paddle pause, meaning the paddle position is going to be what we're determining here. So the vector2 paddle position is going to equal, and this is going to look a little weird, but we're going to create a new vector2, and notice we're putting this in an update. So we're declaring this is the current paddle position, and now we're going to create a new paddle position based on these inputs. And inside here, we're going to use mouse position, and then transform.position.y. So transform.position. Transform, you might recognize that word as something you have vaguely seen before. So on our paddle, that's not our paddle. On our paddle, this is the transform component, and the position of its y right here is -4.5. So it's basically saying that we're going to take the mouse position's x and we're going to use that, but we're always going to stay at the same y position no matter what. It's a very useful way of making just only horizontal movement. And then now that we've got our new vector2 set, we need to just say transform.position equals paddle pause. So in the update method, it's basically saying constantly check for your mouse, find the paddle's position, say that the paddle needs to move according to what the mouse does, and then reset the paddle's position. And it will do this repeatedly, just in a cycle, because it's in the update method. So if we save this, Control S, remember, make sure it's saved and there's no asterisk at the top. It's not going to act exactly the way we want it to just yet, but let's look at what happens. So now the paddle will move according to where the mouse moves, and the ball is kind of flying off into the distance. We'll deal with that in a second. So basically, this is following, but wouldn't it be much nicer if the paddle couldn't fly off the edge of the screen? How many games have you played where your whole cursor just completely goes off the edge of the screen? So the next thing we've got to do is we have to figure out how to limit how far the paddle can go. So whenever we just stop the play so we get everything back where we want it, let's deal with this whole everything can bounce off the sides kind of thing. So we don't want our ball bouncing into infinity, right? We want to set some limits on it. So let's go ahead and in here, let's make a new empty, and let's call it wall. And right click on the transform and reset it. And then let's grab the move, set it over here because we want it on the left side for now. We're going to add a component, add a collider, and now let's make this collider nice and large by stretching out this whole shape. Oops, I did a thing. I zoomed in. This is interesting. Give me just a second to plug in my mouse so I can actually use this like a normal person instead of using my touchpad. All right, there we go. There we go. Okay, grab my wall. And we're gonna scale my wall. So let's edit the collider. Oh, never mind. Edit the collider. And actually grab this point and let's stretch it. Boop, boop, And I'm just going to make it however wide I want it to be. And I'm going to copy this. So I'm just going to click on it and hit Control D to duplicate it, and then drag it over to the other side. There we go. So now all my ball should bounce off of this wall. We probably want one for the top too, right? So let's go ahead and duplicate that and edit this collider. I'm going to put it just a little bit higher because I don't want to accidentally interfere with our goals. No, actually, I'm going to move it down because it should enter the goal before it gets to the collider. And we still need it to bounce off of the wall normally. One interesting thing we can try to do here is kind of adding tags to our walls, or adding these little color boxes to our walls so that we can actually see them a little bit to know that they exist in these places. It's not important, but basically how you do it is you click on the object that otherwise would be invisible, and you go down here where there was before there was a box that looks like, do I have anything else? Oh, yeah, it looks like this. And you click on it, and in the drop down you can click on an icon for it just to make it so that you remember that they're there. And let's go ahead and take all of these and let's rename them. So this is our left wall. This one is our right wall. And this one is our top wall. And obviously we don't need a bottom wall because we do eventually want to create something where the player can fall through and die. But for right now, we'll just deal with the bouncing and worry about all the other behaviors later. And so I'm going to right click on all, or I'm going to select all of these, and nope, I'm going to click below them, right click below them, and I'm going to make a new object called barriers that's just empty. And then I'm going to take all of these and drag it into it just to keep my hierarchy clean so I don't have to look at those all the time. Perfect. Okay. Kind of a lengthy little sidebar there, but at least now our ball won't just fly off onto the sides. It'll actually bounce off of the walls. Okay. So now that we have our information here that tells our game basically to look for the mouse and decide where it needs to go. What we need to do is we need to figure out what is the minimum distance we want our paddle to go to the left and what's the distance to the right. So let's go up here to the top and serialize a field. This is going to be another float. And we want to set our minimum of our x equal to 1f, meaning the units that we've set up on the screen basically just means that it will not go past, like, into the negatives. It will only go all the way over to 1 on the left side. And then we need another serialized field that is a float max x. And this one's going to be 15. Just initialize it at that. Down here we have to change just a little bit. So we are going to take this and we are going to replace the mouse pause and units because we're going to use it somewhere else. And we're going to say just get the transform dot position dot x of the paddle currently. And right underneath this line, before we get to resetting the transform position to the paddle position, we're going to set the paddle position's x, only the x, right? Because we don't need to change anything else about it. MathF.Clamp. MathF.Clamp is a really very useful type of code that we are going to be using in this case to make it so that our game has a limit, basically. Like I think of it as like the number being the math part and the clamp being you can't go past this position. You just can't. It's not possible. So I'm gonna save this. Let's see how this looks in our game now. Oh, that's not Unity. There we go. Let's see what this looks like. So now it goes really far to the right, and it doesn't quite, it stops right here. So let's figure out what's going on there. So let's look at our paddle. Here's where the serialized field comes really in handy. The serialized field, now we have our min x and our max x, and we know that that is the problem. So here we can do a little bit of troubleshooting to figure out why it's not in the right place. So let's hit play. And we see how it's acting. If I zoom out a little bit, I can see that it's clamping right over here. So I know I need to change my value. So I'm going to click on my paddle in my hierarchy here. I know my min x is definitely way too high. So instead of that, let's try negative 7. Okay. Click back on my screen. That makes it so that it hits the edge of our screen perfectly. So I still clamp way over here where it thinks 15 is. So let's say positive 7 because I have a symmetrical screen. And that makes it so that it bounces right on either side. Perfect. That's all I ask for. So here's the problem with changing it down here. So now I know I've used these two numbers, but it's at runtime, so the changing of it doesn't matter because whenever I hit play to turn it back off, the values kind of reset. So I'm going to go back into Visual Studio because I know my numbers are wrong here. I'm going to change my min x to negative 7 and my max x to regular 7. I'm going to save it. And then once it's been saved, go back into Unity, let it initialize. Whenever I click on my paddle, my min x and max x still stay the same. Let's change them here. And positive 7. Let's apply that to the prefab to make sure it stays that way. When I hit play, does it stay? It does. Perfect. So now we have it so our paddle moves and it clamps to either end of the screen, which is exactly what we want. We want to be able to only go to those points. And you can actually see, here's an easier way that I could have done this. So right here, because we've set our world scale, this tells me all the information I need. So it is saying our x position right here is 7, and our x position way over here is negative 7. That's all I really needed. So always double check your stuff, guys. That's basically what the point of this is, and that I am not all-knowing, and sometimes I make mistakes too. And you just have to troubleshoot them. Just have to figure out where the mistakes came from. So now we have a moving paddle. Our next goal in the next video is going to be attaching the ball to the paddle so that until we choose to shoot it off, it will be stuck there and it will follow the paddle around. So we'll have to make a new script for that and we'll put it on the ball and we'll do all that fun stuff in the next video.